Okay, so now we're going to go through some examples where we're going to evaluate definite integrals involving the natural exponential function. So let's look at this first one we got. The integral from 0 to 1 of e to the negative x dx. So we're going to use U substitution, and we're going to make u equal to negative x, and then du will be negative dx. We don't quite have negative dx, but we got dx, so we're going to then make this negative du is equal to dx. And then we can rewrite our integral as negative e to the u du. Now here you have two options. You can leave the endpoints like blank, like don't put any, integrate this, and then resubstitute negative x in for u, and then evaluate the definite integral with the endpoints in terms of x. Or you can rewrite the endpoints in terms of u and just evaluate the problem from there and never have to switch back. I prefer to just evaluate the endpoints in terms of u. So what I would do is then find what would u be when x is 0 and when x is 1. When x is 0 and when x is 1. And we just have to use this equation. If u is negative x, when x is 0, u is going to be 0. So then that endpoint stays as 0. And if u is negative x, when x is 1, u will be negative 1. So we're going to integrate from 0 to negative 1. That'll be our new integral here. So let's go from here. We got, this just becomes a negative e to the u from 0 to negative 1. And this becomes a fairly simple integral to evaluate. This will just be negative e to the negative 1 minus negative e to the 0. Negative e to the negative 1, we can rewrite that as negative 1 over e minus, or minus a minus, so plus e to the 0 is just 1, so plus 1. So it'll just be negative 1 over e plus 1. If we want to convert this as a decimal, multiplied by negative 1 plus 1, and our answer will be about 0.6321. All right, problem B, we got the integral from 0 to 1 of e to the x over 1 plus e to the x dx. So we're going to make u 1 plus e to the x. Then du will simply be e to the x dx. And that's exactly what we got left over, because this is our u, and what we got left over is e to the x times dx. So it works out perfectly. So we can rewrite our integral as simply the integral 1 over u du. Now, let's make these endpoints in terms of u. So we're going to have x is 0 and x is 1. So when x is 0, u will be 1 plus e to the 0, or 1 plus 1. You can see the 0 is 1, and so u will be 2. So we'll have 2 as the bottom endpoint. And when x is 1, u will be 1 plus e to the 1, or 1 plus just e. And let's leave that as 1 plus e for now. So the top, we're going to integrate from 1 plus up to 1 plus e. And so let's integrate this. So remember, if we have 1 over u, the antiderivative of 1 over u is going to be the natural log of the absolute value of u, because the derivative of the natural log of the absolute value of u is just 1 over u. And we're going to integrate this from 2 to 1 plus e. And it sometimes confuses students, but just go with it. 1 plus e is just a number, 2 is just a number, and the natural log of the absolute value of any of these is just another number. So just don't let that intimidate you or scare you off. So here we're going to have the natural log of absolute value of 1 plus e. And that's just going to be 1 plus e because absolute value of 1 plus e is just a positive number, which is the same thing. So natural log of 1 plus e minus the natural log of the absolute value of 2, or the natural log of 2, which 2 is already positive. And then from here, we can rewrite this as a more, as a different form. But let's just go ahead and calculate what this would be with our calculator to get a decimal approximation. So natural log of 1 plus e, whoops. Minus the natural log of 2. We'll get about 0.62011. And let's go through one more. So here we have the integral from -1 to 0 of e to the x times the cosine of e to the x. So we're going to make u e to the x. And du will just be e to the x dx. And now this may be a little weird, but like it works out because remember, you can integrate the cosine of something as long as it's, you know, something simple that we know of. In other words, we can rewrite this as the integral of the cosine of u because we have e to the x dx left over. So the cosine of u du. And now let's rewrite those endpoints in terms of u. So we have x is -1 and x is 0. So when x is -1, u will be e to the -1. So the bottom endpoint, we're going to have e to the -1. And when x is 0, u will be e to the 0 or just 1. So from here, we just integrate what function has a derivative that's the cosine of u. You should know it's sine of u. And we're going to go from e to the -1 to 1. So evaluating this, we'll have the sine of 1 minus the sine of e to the -1, or let's just write that as 1 over e, same thing. Now let's see what we get. Sine of 1 minus sine of, I guess I might as well just left it as e to the -1. I'm going to get 0.4818. Now make sure your calculator's in radian mode, because if you have it in degrees, it's going to give you a different answer, because it's going to think of that 1 and that 1 over e as two different values. Unless the problem specifically says use a different unit for the trig functions, always assume degrees. Always assume radians. Always assume radians. All right, so I hope that helps.